Hello everyone, and welcome to the first part of the lecture notes for section 2.5 about applications of linear equations and also modeling. I was talking about modeling. Of course, we can make linear models for a lot of different situations, and we'll see an example of that here in a second. But the first thing that we're going to talk about, and we touched on a little bit in the previous section in 2.4, which is another formula that we have for lines. This one's called point-slope form. And of course, where the point-slope form comes from, I can just draw a little picture here. Here goes an x and y axis. And the point, no pun intended there, of the point-slope formula for a line is that you will be given a point that a line goes through, and then you will also know the slope for that line. And so with those two pieces of information, we will have a point here. Let's call this one x1 and then y1. And then we will say that this line has a slope of m. Well, of course, whenever we make an equation of a line, what the equation is telling us is which pairs, like x and y, will satisfy that equation, make the equation correct. And so it doesn't matter which point on the line you pick. If you just pick one, that pair of x and y coordinates will satisfy the equation. So what we can say is that this other point, it can just be basically any point that's along this line. It can just be floating anywhere along here. It doesn't matter which one. We'll just pick one and say that the coordinates for that point are x, y. And then we know the equation for the slope of that line is we would just do, for example, we can pick, I will just pick, for the purposes of this example, I will pick this point as the first point. So it would go y minus the y coordinate for the second point, which is y1. And then we would want to divide by the change in x, which it's going from this value x to the other point, which is x1, so we'd go minus x1. And if we just do one simple step here, all that we would have to do is actually multiply both sides of this equation. I'll write it this way. Multiply both sides of this equation by this denominator on the right side, x minus x1. And what will happen is that on the left side, it would just go the slope times x minus x1. And then on the right side, we have basically this thing, y minus y1 over x minus x1. And it's being multiplied times that x minus x1. And here, that denominator will just cancel. So it would just become y minus y1 on the right side. And we could carry on simplifying this one. We could solve for y, for example, and then simplify the other side. We would end up with basically the slope-intercept form. But if we just stop right here, we would have the point-slope formula for a line. And so this one, it's really convenient because a lot of times you'll know a point that the line passes through and then also the slope, and you need to come up with an equation. Most of the time the acceptable equation that we want is slope-intercept, but you can always, like we saw in previous examples, you can start by finding the point-slope form and then just simplify it a little bit to get the slope-intercept form. So that's what we're going to try to do here. You notice it says if possible because not every single line really has a slope-intercept form, especially we will see this example over here, probably example 4, it's not really going to have a slope-intercept form. And I want to just recall slope-intercept is the one that goes y equals mx plus b. That's what we're trying to obtain for these. So for number 1, we have a point that the line goes through, which is negative 4, 2. And so this is the point like x1, y1 from the formula. And then we have the slope. So really we would just plug it in. We just go y minus y1, which is 2, equals the slope, will go here, and then it will go times x minus x1. But x1 is negative 4, so it's minus negative 4. And so now we can simplify a little bit on the right side. I would just go minus negative 4 will make x plus 4. And then we can distribute the 2. And of course, the way that you go about this particular simplification process is not important, but it will go y minus 2 equals 2x plus 8. As long as all of your steps are mathematically sound, it's no big deal. And so here, to get rid of this -2, or the -2 rather, we got y subtracted by 2. We would want to add 2 to both sides. And then I would just continue on this side. The -2 and +2 cancel. It just goes y equals 2x plus 10. And so that will be our slope-intercept form of a line. Now, I want to think about for number 4, what is the deal with this one where it says the slope is undefined? Now, just think back for a second, which type of line has an undefined slope? You would recall that since the formula for, we were just looking over here at the formula for the slope, in the denominator is the difference of the x values. So if that is 0, if the difference of the x values is 0, which of course occurs for a vertical line, the slope will be undefined. And so we have here, this is supposed to be x equals 2, and then here's y equals 3. It's telling us that our line goes through this point, 2, 3, and that it has undefined slope. That means vertical line. And so here we want to write the equation of a vertical line. We can't really do point slope formula because we don't have a slope. The slope is undefined. There's nothing to plug in there. So we are going to do our best, which is just to write the equation of this line, which of course a vertical line just goes x equals something, in this case x equals 2. Not able to use the formula, also not able to achieve the slope-intercept form because there's no y in there, it just goes x equals 2. But we are done for that one, and we will pick up with a couple of applications in the next video, applications for linear equations and modeling, and then we will be moving on to bigger and better things. So thank you guys for watching this one, and I'll see you guys in the next video.